All right, so in the last set of lectures, we talked about the simple experiment. And today we're going to expand on that a little bit and talk about the multiple group experiment. So in just a moment, we'll explain what that is. But as an overview for today, this first lecture, we're going to talk about the advantages of using more than two values of an independent variable. In other words, the advantages of a multiple group experiment over two would be a simple experiment. So that's what this first lecture will be about. And then the second lecture, we're going to talk about how you go about analyzing multiple group experiments. So this is the first day we're going to get a little bit into the statistics. You're not required to remember it or to know how to do it, but I am going to show you some numbers in the next video, in part just to sort of systematically desensitize you. Show you them, let the anxiety come down, and hopefully unpack a little bit about what those numbers mean. But to begin with, I just want to remind us what the simple experiment is. So remember, in a simple experiment, I have an independent variable and at least one dependent variable. In a simple experiment, my independent variable has two levels. Remember, the IV is what I'm manipulating. And the dV can have multiple different levels. Usually it is continuous, but not always. What that means, or a ratio variable or an interval variable, what that means is you can have small amounts of the dV or high amounts. For this example right here, I want us to imagine that our IV, our independent variable, is a drug. We want to know if a drug that we're going to give our patients increases happiness. So our independent variable is going to be giving them the drug or not, and our dependent variable is going to be their happiness level. So I just want us to think about that. That'll be today's example. So drug and happiness level. Now, in a simple experiment, what we do is we divide our participants, we randomly assign them to one of two conditions. In the first condition, this would be our control, and they get no drug. And then half the participants are randomly assigned to receive the drug. So we give half the group the drug, the other half no drug. And then what we want to measure is, for this experiment, we want to measure happiness. And so what we end up getting are two different group means. So you oftentimes will see bar graphs like this. And let's imagine that our drug appears to work anyway. In our control condition, the happiness is here. And in our drug condition, the happiness is here. In other words, it appears that the happiness level of the drug group is higher than that of the control group. I know we talked a little bit in the last set of lectures of just because this mean is different from this mean doesn't mean that they're significantly different. So what we have to do is we have to do a t-test to test whether or not those two means are different. And if the p is less than 0.05, we say that these are significantly different. In other words, our drug appears to have had an effect. Okay, so I just want to use that as a background example of what a simple experiment would look like. Because now I want to think about, well, why wouldn't we just use simple experiments all the time? Why bother with a multiple group experiment or having more than two levels of an independent variable? There's a few reasons. One, it may be that we're not just interested in whether or not a drug works, but we might want to compare more than two kinds of treatment. So for instance, drug A, drug B, drug C. Let's say we have three different antidepressant drugs, and we want to know which of these three works better, which is going to increase happiness better. We might want to do an experiment like this, where we take two or more treatments against each other as well as against the control. So here we might have drug A, drug B versus a control. In other words, here in this first experiment, we can tell which is best. Here we can tell not only which is better, but when we compare them against the control, do they do anything at all? In other words, it may be that drug A is better than drug B, but the both of them are worse than if you'd done nothing at all. Okay? When we do this, three or more group experiment allows us to better estimate the effects of different levels of a treatment. So we might take, for instance, drug A 5 milligrams versus drug A 10 milligrams, 15 milligrams, and actually 0 milligrams, which would be our control. So it lets us know, well, maybe happiness improves when you give them 5 milligrams, but maybe it goes back down when you give them 10 milligrams. Maybe that's too much of the drug. And it better allows us to rule out confounding variables. So for instance, how a treatment or how a manipulation is presented might have a greater effect than the treatment itself. So let's say you had a doctor give you drug A, and then let's say you had just a pharmacist recommend drug A. Maybe the drug actually works better when, so we'll say doctor versus pharmacist versus a student in the lab. And let's say maybe, and they're all getting the same drug. Well, it may be that when the doctor gives them drug A, they end up scoring the highest on happiness. And when the student gives them drug A, they end up scoring the lowest, in part because of the placebo effect. They don't believe that this is really going to be an effective drug with the student. So in other words, there's lots of ways in which multiple group experiments can help us to identify either other confounding variables or to compare different types of treatment against each other and against an empty control group. So why might we compare more than 2 levels of an independent variable? Well, there's a few reasons. Remember, that's where we give 5 milligrams versus 10 versus 15. Well, one reason is that it might help us to actually discover significant relationships. It might be that 5 milligrams is no different than 0 milligrams in terms of the happiness. But maybe 10 milligrams is a greater levels of happiness than 0 milligrams. If we'd only done our experiment with the 5 milligram case, we would have ended up with non-significant results because we missed the treatment effect. If we use this, then if we use 10 milligrams, then we can actually detect a significant difference. It might also help us to better map the functional relationship. In just a second, on the next slide, I'm going to talk about what a functional relationship are. But although 2 levels of a variable might not differ significantly, a third level might. That's this one right here. For a functional relationship is the specific way in which 2 variables relate to each other. So these can be, like for instance, the number of milligrams of a drug and happiness. These can be linear, either positive or negative. They can be quadratic. They can be logarithmic. There's a lot of different ways in which these variables can be related. But in essence, multi-level experiments can have more external validity than simple experiments. In other words, the more levels you have, the more groups and the more situations to which you can generalize. So I want us to take a little closer look at this idea of functional relationship for a moment. So it's easy. Let's imagine again that this is the drug. So let's say we have 0 milligrams of a drug and 10 milligrams of a drug. And we want to ask, how is this drug related to happiness? Well, here, it would be easy to assume a straight line. This is also, it turns out, similar to linear regression that we'll talk about a little bit later. In other words, what this would predict is that someone with a medium level of a variable would respond moderately. But it may also be the case that someone with a medium level of the drug could respond very differently. They could respond worse, they could respond better. In other words, a straight line is not the only line that you can draw between these two different points. The line might go up here, the line might go down here. So let's take a more specific look at this, and let's imagine this with no drug, a medium level of the drug, and a high amount of the drug. Again, I think we use 5 milligrams and 10 milligrams before. So it could be the case that here a medium amount of the drug, 5 milligrams, might cause a medium level of happiness. If this were the case, we would see that there is a linear functional relationship. In other words, all of these best line up on a straight line. However, maybe we do our experiment, and when we test the 5 milligram group, we find actually that 5 milligram group does almost as well as the 10 milligram group. In other words, what we might find here is we're actually wasting drug if we give them 10 milligrams. You might as well just give them 5 milligrams and get the same amount of treatment effect. Alternatively, we might find that a low amount of that a medium amount of drug actually gives us a worse level of happiness than if we'd done nothing at all. In other words, nothing, 5 milligrams actually does worse. So this might be in the kind of situation where you give someone 5 milligrams of a drug and it's just enough to induce side effects, let's say, that reduce happiness, but is not enough to get a clinical response at the level of neurotransmitters. Okay, all that to say, when you have a multi-group experiment, you can begin to see, are these variables actually related in a linear fashion, or is there some other kind of relationship that's going on? So you can also use multiple groups. Oh, and it could be that this medium level group is actually the best. So here, maybe it turns out that if you give them 5 milligrams of the group, or 5 milligrams of the drug, you improve happiness tremendously. And when you crank it up to 10 milligrams, it actually drops happiness back down again. And again, this could be because that 10 milligram level, maybe it causes other side effects, or it overwhelms the system. But all that to say, doing a multiple group experiment allows you to see this functional relationship. So again, this is what a functional relationship looks like here. Okay, and if we have 2 levels, we can test one kind of relationship. So 2 levels, we can test a linear relationship. We'll go over this again a little bit later. 3 levels allows us to test a quadratic relationship. In addition to linear, we can test to see whether these variables are related like a parabola, which would be a quadratic relationship. And 4 levels is a cubic relationship. So for instance, we might find this with 4 levels, that the drug goes up to a certain point and then takes off. Again, we'll go over this again, but I wanted to at least tie this back into this notion of functional relationship. So one reason to use multiple levels of an independent variable is to detect the functional relationship between one variable and another. Next, you may use multiple groups to improve the construct validity of experiments. So multi-level experiments can actually help us to identify potential problems with our control group. Okay? What are those problems with our control group? Well, every control group is imperfect in some way. And when you use multiple different imperfect control groups, you can actually account for some of the problems with one imperfect. So for instance, here is a problem that may go wrong. It might be that multiple different treatments are actually confounded with one another. So let's say you give someone therapy for depression. And so you give one set of people cognitive behavioral therapy, one set of people psychodynamic therapy, and then a third set of people get nothing at all. They're an empty control group. And lo and behold, you find that both of your treatment groups get better. Well, in addition to therapy, you have to think about versus nothing. You have to think about what else is this therapy group getting. Certainly, they're getting the actual treatment of choice, CBT or psychodynamic, but amongst other things, they're also just getting human attention. And maybe attention itself is enough to relieve depression. So what you'd want to do is you'd want to create a third control group that is an attention-only group. Maybe these people get to go and hang out with someone, but that person doesn't give them either CBT or psychodynamic therapy. They just give them attention. So in other words, there's lots of things that could go wrong with your group. Let's think about what can go wrong. So two of the traditional types of control group are the empty group and the empty control group and the placebo control group. An empty control group is one in which there's some participants who get no treatment at all. Okay? In other words, many of your simple experiments involve giving some people a treatment and in other people no treatment at all. A placebo control group is where some participants get a treatment that's not actually expected to make a difference in the DV, but they think it will be. The easiest way to explain this is with drugs. So let's take our drug group that we had before, where we had drug A, and then we had a control. Let's say this empty control group gets nothing at all. Well, then we want to give them a placebo as well. So what would a placebo look like? Well, if we were giving these people in group A a little round white pill, we would want to give these people in the placebo group a little round white pill, except these people would get a sugar pill, and these people would actually get the drug. These people in the empty control group would get nothing at all, not even a little round white pill. So why would you use these? Well, I want you to take a moment and jot in the text box below why you would use an empty control group, what that tells you versus a drug, and why you might use a placebo control group. Do your best. As long as you try and answer this in some way, you'll get credit for this. But I just want you to try to think, what is an advantage of the placebo group and what's an advantage of an empty control group? When you're done, you can unpause the video and come back up here. Well, with an empty control group, there's a few things you can know. One, you can know what is the baseline level. In other words, with people going about their business just as they are right now, what is their level of, in our experiment, happiness likely to be? When you compare, then, your drug to this baseline, you can tell if it has a positive effect. In other words, I can know whether or not giving people my drug actually makes them happier than they would be normally, or if it makes them worse than it would be. What we can't tell, so this is the downside of an empty control group, is we can't tell if the variables are affected by our treatment or sometimes TX we use to refer to treatment, are affected by the treatment or by, and I'll just say attention here, or by the attention they get, or by the expectations that they might have. So it may be that people who get a sugar pill up here expect that pill to work. And so they actually get happier. Turns out there's actually a pretty robust effect for placebo pills. Okay. Um, in a placebo control group, we have a couple of advantages. One, you can tell if your treatment is changing more than an ineffective or a null treatment. In other words, with just a sugar pill. And you can use this to weed out confounding variables. In other words, in this placebo group, you can give people multiple different aspects of the treatment that you would be giving to the drug treatment, but just withhold the chemical compound inside that drug. Or if you're giving them therapy, like we talked about before, you can have them come to an office and sit in a waiting room and sit with a therapist for an hour, but just have that therapist not do anything that involves cognitive behavioral or psychodynamic therapy. Just have them talk to them or ask questions. When you have both of these, both the empty and the placebo, what it does is it allows you to estimate the magnitude of the placebo effect. So both allows you to measure the placebo effect. In other words, you can tell how much people's mere expectations increase their levels of happiness. So why wouldn't you just do this all the time? Why doesn't every study end up having both? Sorry, that's right underneath all the writing. Why don't you do this all the time? Well, because of expenses and time, lack of participants. And in fact, depending on your hypothesis, you might not even need a control. Maybe you just want to compare CBT to psychodynamic, and your only question is which of these is better. You don't care if either of them are more effective than doing nothing at all. It may be, oftentimes, for instance, an outcome study simply hypothesizes that one treatment will work, and they don't really concern themselves with why they work. If they work because of the placebo effect, so be it. But in contrast, so in other words, let me jot this, sorry to crowd up here. So an outcome study, you can have an empty control group and be just fine. Because an outcome study just wants to know, does it work? For a process study, now you need some kind of a placebo group. And this is because process studies want to know, why does it work? For instance, does it work because they're getting attention from a therapist? Does it work because they believe that this drug is going to help them? And so those kind of studies, you might need a placebo group. And it's up to you as an experimenter to decide which of these two types of control groups, or both, are you going to need. Okay. The last thing I want to mention is one very common confounding variable. It's a variable called the Hawthorne effect. So this is one of my favorite studies. This was a study that happened nearly a century ago now at the Hawthorne Works. This is a Western electric factory. And what they wanted to know was, how can you make your employees work faster, work better? And so in this study, what they found was that any change in lighting improve people's productivity. So for instance, what they found was they wanted to know, and they're working at an electric factory, maybe if we increase the lights in this factory, people will work harder. In fact, you can see the self-serving bias of that one, right? If you turn up the lights, you have to use more electricity. And if you have to use more electricity, then people are going to buy more electricity. And this is what they found. They turned up the lights, and sure enough, workers worked faster. They were more productive. But they came back a little bit later. They wanted to test an additional level of the variable. They said, well, let's see what happens when we turn down the lighting from their normal level. So they turned down the lighting, expecting to see that people's productivity would drop off even more. And what they found was people's productivity rose. So if you turned the lights up, people got more productive. If you turned the lights down, people got more productive. The Hawthorne effect is the finding that a temporary change in behavior results due to a change in the environment. In other words, doing anything can tend to improve people's behavior. The environmental change can be almost anything. So this study of the Hawthorne Works employees found that any change in lighting tended to improve their productivity. What was the key? Well, it was what we mentioned earlier, which is that attention matters. Attention matters. So why were these employees getting more and more productive? The employees were more productive because they knew that someone, the experimenter here, was paying attention to how much they were working. So when the lights went up, it cued them off. Someone's watching how we're gonna work. We're gonna get more productive. So what I want you to think about and jot down below is, how does each type of control group help? And we'll talk about this briefly in class. How would each type of control group help here? How would an empty control group help? How would a placebo control group help? Would both of these be helpful to eliminate or identify the Hawthorne effect? Would only one of them? Would neither of them? So jot your answer down in the box below, and when you're done, you can go on to the second video.